Last class we have discussed relations and functions. Relations. Today we have to study functions. Functions. See, you have just defined a function. You have studied the definition of function in first year. So first we have to understand what is the meaning of a function. And in our second PU syllabus, we have to learn types of functions. So first, let us define a function. See, we consider two non-empty sets. Let A and B be two non-empty sets. A function, a map f from set A to set B is a function if, see, that is, look here, once we will begin with very simple definition. You have to first understand the definition of a function. See, set A to set B, and we know that elements of set A, they are called domain elements, and elements of set B, they are called codomain elements, and the images are called range elements. See, A is having an image 1, B has image 2, C has image 2. So the images are unique. So the mapping f from set A to set B is a function if all the elements of set A have unique images in set B. So this is the simplest definition, very simple. So set means, a function means elements of set A are mapped onto elements of set B under this map f. This map f is said to be a function only when all the elements of set A, they are having unique images. See here, A has got image 1, B has got image 2, C has got image 2. So the elements 1, 2, the set, that is called range set, range elements. So here, see, generally we write this is A is the element of set A, 1 is the image. So I am writing f of A is 1. F of A is the image of A under f. Okay, what is f of A? Image of the element A under f. See, we have f of B is equal to 2, f of C is equal to 2. Okay, f of C is equal to 2. So it is said to be a function provided all the elements of set A, they have unique images. I will just write one example. See, you consider a mapping, say from set A to set B. Now this is ABC, 1, 2, 3, 4, 5, A to 1, B to 1, C to 3, C to 4. See here, f from, this is the notation, f from A to B is not a function because C belonging to A has two images, C belonging to A has two images. See, C has got image 3, C is mapped onto 4. Therefore, the image is not unique, hence it is not a function. Okay, so this is the basic definition of a function. This is what you have studied in first year. Always remember, see, these concepts are very important, these terms, domain, codomain. Actually, when we solve objective questions in any of these competitive exam, we may have to define domain of a function, codomain of a function, or range of a function. So you should know what is the meaning of domain. Domain means set of all elements of the first set. Codomain means set of all elements of the second set, whereas image elements are called range elements. Okay, so remember these terms. With this, let us study types of functions. Types of functions. Let us learn this. See, this is our second year. So we have to study different types of functions. First one, that is one-to-one function, one-to-one function, or injective function, one-to-one function or injective function, one-to-one function or injective function. So I'll just give you one example, then I'll give the definition. See, let us consider set A and set B. Consider the elements A, B, C, 1, 2, 3, 4, 5. A is mapped onto 1, B mapped onto 2, C is mapped onto 3. That is, distinct elements of set A have distinct images in set B. So a function f from A to B is set to be one-to-one function or injective function, set to be one-to-one function or injective function if distinct elements of set A have distinct images in set B. Distinct elements of set A have distinct images in set B. See that, read the definition. That is, I have mapped on the elements of set A into set B under this function f. Now it is said to be one-to-one if distinct elements of set A have distinct images. Say A is mapped onto 1, B is mapped onto 2, C is mapped onto 3. Now I'll write one simple example. See, one simple example. I am define f from n to n. N means natural number. N to n by f of x is equal to 2x. F of x is equal to 2x, or I write f of x is equal to 3x. I am defining a function. Now see, let us consider, we have to find whether this is one-to-one. See, we define the function n to n. What is n? N means set of natural numbers. So it is set of natural numbers. Now x is 1, 1 is mapped onto, or I write x is equal to, one simple example, x is equal to 2x, 1 means 2. Why? F of 1 is equal to 2. Why? F of 1 is 2. F of 2, that is equal to 4. So 2 is mapped onto 4. Similarly, 3 is going to 6. 4 is going to 8. Okay, 4 is going to 8. So now we observe that, see, distinct elements of set n, that means domain set, have distinct images here. So f is one-to-one. F is one-to-one. See, one-to-one means, in our simple language, say to understand this, one element must be mapped onto only one element. See, 1 going to 2, 2 going to 4. That is why I say distinct elements, different elements have different images there. I'll give you a set theoretic definition. See, to solve problems, here I have only given the definition. To work out problems in a one-to-one function, we need some more ideas. Better definition to work out problems. See, just look at this function. Say function is a to b. Let us write a, b, c, 1, 2, 3, 4. A going to 1, b going to 2, c going to 3. Now we observe that, see, f of a equal to 1, f of b equal to 1, f of c equal to 2. But this is not one-to-one. This is a function, but this is not one-to-one. Now a function, I'll give you one more definition. The same definition can be modified like this. A function f from a to b is one-to-one if look here, this is x1, x2. So I am writing A, this is A to B, F. Now we can write if for all x1 comma x2 belonging to A, f of x1 equal to f of x2. See here, f of x1, this is A equal to f of x1. Again A equal to f of x2. So we can write f of x1 is equal to f of x2. So images are equal. Okay. Now if you take, this is not 1 to 1, this is a function. Why? F of A is 1, f of B is 1, f of C is 2. A and B distinct elements do not have distinct image here. Both A and B are mapped onto 1. Now this function becomes 1 to 1 provided A is equal to B. That is what? When the images are equal, their pre-images must be equal. So if we write f of x1 is equal to f of x2, if that implies, this expression implies the images are equal, pre-images for A, pre-image x1 and x2. So if x1 is equal to x2, then the function is said to be 1 to 1. So a function f from A to B is 1 to 1 if for all x1 comma x2 belonging to A, f of x1 equal to f of x2, that implies x1 is equal to x2. So while solving problems, we are generally verifying the 1 to 1 condition of a function by using this definition. Onto function or surjective function. Surjective function, onto function or surjective function. So what is this onto? Here 1 to 1 means f of x1 equal to f of x2. That implies x1 is equal to x2. So it shows that distinct elements have distinct images. Then the function is onto, 1 to 1. Whereas when we go to this onto, see, now I'll just write some example, then I'll come to this statement. See, let us take an example. You consider a function f from A to B. Take it as f from A to B. See, take the elements 1, 2. A is mapped onto 1, B is mapped onto 1, C is mapped onto 2. A is mapped onto 1, B is mapped onto 1, C is mapped onto 2. This is onto. I will write one more example. Say A to B. This is F. A, B, C, 1, 2, 3. A to 1, B to 2, C to 3. So what is the conclusion now? Or what do you understand? See, that is function is said to be onto in a very simple idea. All the elements of set B, all the codomain elements are images. See, here I have written those elements which are the images of the elements of set A. Again here all these are images of A. See, 1 is image of A, 2 is image of B, 3 is image of C. Suppose if you write say 4 here without being an image of any element of set A, then this is not onto. Why? Onto means all the elements of set B are images. That means for some elements of XA, there must be an image in set B. Okay, image in the set B. So function is said to be onto. That is a function. Say a function f from A to B is said to be an onto function or surjective function if all the elements of set B means codomain, are the images of some elements of set A. some elements of set A, images of some elements of set A under this function f. Okay, under f, under f means under the function f. So observe this, 1 to 1 means, what is the meaning of 1 to 1? Distinct elements have distinct images. See, this is 1 to 1 also. Here you can write A going to 1, B going to 2, C going to 3, right? The function is 1 to 1. Why? Distinct elements have distinct images. Is the function 1 to 1? No, because two elements have image 1. So this is not 1 to 1, whereas this is 1 to 1. But at the same time, all these elements are images. Therefore, this is onto. See, I will write an example now. Let us consider set A to set B. Observe this, A, B, C, D, 1, 2, 3, 4, 5, 6. A going to 1, B going to 2, C going to 3, D going to 4. What about this function? This function is f is 1 to 1 but not onto. Why? F is 1 to 1 but not onto. Why? The elements 5 and 6, they are not images of any elements of set A. They are not the images for some elements of set A. They are not the images. Therefore, the function is not onto. This is 1 to 1. So remember, these are the range elements. So if the range of the function f is equal to the codomain set, suppose if this is the codomain set, if the codomain set is equal to range of the function, range means image of the say elements. So if this codomain set is equal to range of the elements, range set, then the function is said to be onto. Okay, the function is said to be onto. So what is the condition for a set to become an onto function? Condition is no element in B can be left out without being an image of any element of set A. All the elements of set B must be images. Okay, they must be images of some elements of set A. Is the idea clear to all of you? Just note down this. Okay, now once again, see, I have just explained this onto function. Once again, we need some ideas to work out problems later. So to define or to work out the problems, we need some more information or some more definition of onto. See, totally onto means, look here, let us consider that sets, non-empty sets A and B under this map f, function f. Now for the function to become onto, only one condition is all the elements of set B must be image of some elements of set A, or there should not be any element in B which is left out without being an image of A. So in a simple idea, all these elements of set B must be images. So let me consider some element y. See, a function f from A to B is set to be an onto function if for all elements of the second set there exists an element x belonging to A. There exists an element x belonging to A. X. So for elements in the set B, you are finding out a corresponding element x in A such that see, you are mapping this x to y is equal to f of x, such that y is equal to f of x. So a function f from A to B is said to be an onto function if for all y belonging to B there exists an element x belonging to A such that y is equal to f of x. That means for whatever elements in y, second set B, codomain set, you are finding out a corresponding element x in the domain set, so that there is no possibility of getting any element in B without being an image of any element of A. So it actually describes the onto function. So onto means all the elements of set B are images. So it's very simple. Now function is a function f from a to b is onto if range of f is equal to b. What do you mean by this? Range of f is equal to b means, tell me what is the meaning of range of f is equal to b? That is, range of f is equal to b means b is the codomain set. So codomain set must be equal to the range. Codomain set must be equal to range. See here if you take the previous example, that is a, b, c, they are the elements of set A. Codomain is 1, 2. So b is 1, 2, but range is 1, 2. So range is equal to codomain, or range of the function f is equal to the codomain set. Then the function is said to be an onto function. So function is onto if all the elements of set B, they are images. Function is one-to-one if distinct elements of set A have distinct images in set B. Okay, distinct elements of set A have distinct images in set B, whereas onto means all the elements of set B are images. So for all y belonging to B, you are first finding an element y in B. For each y belonging to B, you are finding out a corresponding element x in the domain set, such that this y always becomes the image of this x. Okay, y always becomes the image of the set x. Y is the image of x. Just observe this. So we have studied both the definitions, one-to-one and onto. So you have to practice this. We will be solving problems based on one-to-one and onto. Later we have to solve problems on finding inverse of a function, which will very important for final exam. 1 5 marks question will be asked from that, and once if you know the definition of one-to-one and onto, you can easily solve problems in the next section.